Hey everyone, Brian Beeler here with the Storage Review Podcast, and today we're talking all things PowerScale and what's going on with that line of products from Dell. There were some big announcements at DTW back in May, and now some of these things are coming to market, which is really exciting to see. I've got David Noy with us today. David, thanks for jumping in.
Hey, thanks for having me.
So, yeah, I'm glad to do it. Glad to talk with you. I mean, you guys had all sorts of great announcements at DTW. Sometimes the hardware was a little bit behind the software offerings. But before we get into all of that, just what do you do at Dell? Give us a little background on yourself.
No problem. So I lead product management for our unstructured data solutions team, which is our scale-out NAS offerings, so PowerScale, and as well as object storage, ECS, and then the software-defined version ObjectScale. I also lead product management for our data protection suite. So that's the PowerProtect DD product, all of our software assets around backup, including our new PowerProtect Data Manager, and things related to cyber recovery and CyberSense.
Okay. Yeah, that I didn't know actually that you did backup too. One of our favorite things that you guys ever did was that little DD Virtual Edition that started to slide into to Rail and some other spots. Was just a neat, like a little data protection widget to just kind of clip into your environment. That was pretty slick. I don't know if you should take any credit for that, but that's one of our favorite things.
I don't know if I can take credit for it, but I'm inherited. We have 13 exabytes, I believe now, of data protected in public cloud on that little DDVE product.
Really? Wow. That's extensive. That's extensive. So take us back a little bit to Dell Tech World. I mean, there obviously Apex was a big messaging driver, and Alpine. I guess you guys like code words that begin with the alphabet, which is cool. Apex, of course, is a service. Alpine being the cloudification of your operating systems and storage software. Just let's start with those. Where does PowerScale fit into those models? How are you guys thinking about the as a service, and then also this cloud delivery model?
So we have PowerScale as a service in Apex today. File on demand, very popular offering. And for customers who are looking for a fully managed service, who want to buy consumption based, and that's the model for them. That capability is out there right now. What we showed at Dell Tech World was a software-defined version of the operating system that runs on PowerScale called OneFS. Mm-hmm. And by moving to software-defined, that gives us the ability to adapt beyond just the appliance model, which we ship today, and even the underneath Apex, there are physical appliances. But as we go forward, to actually deploy OneFS in the cloud as a cloud native service for scale-out NAS.
Yeah, that's ambitious, right? I mean, it makes sense to sort of separate the two components, but the Alpine project's a big one for you guys. I mean, that's obviously a major emphasis in the messaging, but also, as you're talking about it, is something that you're working on delivering too.
So if you think about it, this isn't just a PowerScale or UDS thing. It's across all of the Dell Technologies storage assets.
Right.
We're in the process of making them all become available as both a software-defined consumption model as well as an appliance consumption model, and as Apex as a managed service offering. So customers have their choice. If they want something in the data center, they can get it that way. If they want it in the data center or they want it as a fully managed offering, they're willing to outsource that operation, they can get it that way, either managing it in your data center or hosted. And then as a cloud offering, we're doing that for file, object, block, and our data protection products. So the process, various stages of that process across the portfolio. PowerScale has come pretty far along, and so we're looking forward to what that means. But we demoed the beta, so you can guess as to how far along we are.
Well, typically when Dell shows something, that means you're pretty far along in the process, because you guys don't tend to lead with half-baked kind of solutions. As you're talking about that, I do wonder, and I don't even know how much visibility you have into what happens from a development standpoint for the code, because taking the code off of hardware, I mean, still obviously runs on something, but it's a different development modality than traditional storage array development. And I think there was even a big shift like when Dell and EMC came together to take some of those really traditional EMC storage appliance hardware models and transitioning them to a little more power edgy kind of server models. So you had to make a shift in development mentality there. How different is this going to a cloud delivered model?
Well, you hit the nail on the head. I mean, the first move was to adopt PowerEdge servers as a platform for us to extend onto. And so we've had a lot of success with our all-flash servers, which are the PowerEdge based servers. But in doing that, we had to take a different approach to how we build out OneFS to assume that ultimately we could be run on any platform. And so if it's a PowerEdge platform or it's a compute instance running virtualized in cloud, call it EC2 and AWS or Azure Compute, what have you, that we treat those as yet another platform. And so we abstract ourselves further from the actual hardware so that way we can actually become software defined. What we don't want to do, and you called this out earlier with the development practices, what we don't want to do is fork the code and have two completely different code bases, one that's for cloud and software defined and one that's for the appliance. And so we've kept that as a common code base. The importance there is that I get asked all the time by my customers, when you launch this thing in cloud, is it going to be different from the version that you have on-prem? The answer is it's the same code. Like, largely speaking, it'll be functionally equivalent to what you have on-prem. There'll be differences in performance, probably. There may be differences in the scale, but largely speaking, it is the same code. So if you're used to doing things one way on-prem, you're going to be very used to doing it the same way in the cloud. And that commonality is actually something that's very important to our customer base.
I think it's probably beyond very important. It's like mission critical, right? Because you can't have a storage admin on-prem saying, "Oh, well, this is how we do it in the data center, and spin up whatever, or we use some deep data feature that's within PowerScale, and then go to the cloud and for some remote work and be like, oh, that's not there yet." And we've seen that before, where there's not feature parity between the cloud version of whatever is being deployed and the on-prem, and it causes some conflict.
That's right. Yep. We get the question all the time: can I replicate back to the on-prem if I
replication?
If I run cyber capabilities, we talked about the ransomware defender capability in the on-prem, and I want to do cyber protection of my in-cloud assets. Can I do that? Sure.
So let's stick now with the hardware a little bit. So in May, again, you launched a couple things around OneFS and PowerScale. You had some security stuff, which we'll definitely talk about some more, but also the support for QLC, which is really interesting to me. We've done so much work around QLC. To see you guys from a mainstream array perspective adopt that I think is pretty cool, and really validates that the QLC NAND is there and ready for heavy use in mainstream enterprises. Talk about that a little bit, the decision path there, kind of what you're seeing that from an enablement standpoint for your customers.
So QLC is just a different architecture of flash from TLC in that it adds more dimensions, if you will, to the way the data is stored, but the trade-off is typically endurance and performance. The way that we use those drives is that we're fairly sparing on the endurance. So we're pretty gentle in the way that we use the drives. We do large IOs. We try to be very careful about how we place data. Data that comes into the cluster is not immediately just dumped on the drives. We process it first. And so we've done some calculations using in-field metrics. And what we've found is that we get about 14 years of endurance out of these drives before hammering them in the worst possible ways that we see happen in the field, which is pretty good. I mean, for the longevity of a drive that's supposed to be low endurance, 14 years is a pretty long time. In the worst possible cases. At the same time, we have checks and balances. So we do wear level, checking to make sure that the drives haven't been, for whatever reason, inadvertently worn down. We will alert our support teams if their drives are failed for whatever reason. But largely speaking, we feel fairly comfortable that even with the lower endurance of these drives, because we're using larger capacity drives like 15 and 30 terabyte, where the lifespan of these drives would be quite good. And
Yeah, I've got
so
a couple. I've got a couple sitting on the that just happen to be sitting on the desk here. We've done a ton of work with these the 30 terabyte part, the Solidigm drives, and they're really fantastic from the capacity bump that you get, like you said, up to 30.72 in a drive. And you guys are supporting these, I think, in the F200 and F900 nodes, or is it
600,
600?
600,
600, 900. Anyway, the one will fit 24 drives in it. So 24 30.72 terabyte drives is roughly 750 terabytes in this thing, almost a petabyte in one of these 2U chassis. And you hit
Yep.
on the really important thing, and I was hoping you would do this, because we collectively know from telemetry data what the drives are seeing at the drive level and then what you're seeing at a system level. And with that information, you can confidently go to customers and say, look, guys, it's QLC. There are going to be some trade-offs, and we can talk about that in a minute. But on the upside, your workloads aren't punishing these drives as much as you think or might be afraid that they will. So long as you're under this whatever drive write per day ceiling that you guys set, then so be it. And if the drive fails, it's under warranty. It's not like the customers have much risk here outside
Yeah.
of workload performance.
Yeah, no, we've been very successful with the launch actually. So far, no drive failures. So cross your fingers. But look, you're right. So it's not even just that. Like even under the most punishing environments that we see in the field, like real life environments, these things will endure. And the net of it is, even with the performance profile being somewhat different from TLC drives, the way that we do a lot of prefetch and a lot of performance optimizations, we see the exact same performance with QLC drives as we do with TLC drives. So from a customer perspective, it's great. I get a lower price point and I get more density and equal performance. Like what's not to love, right?
Yeah, I mean, we've seen some of that performance data. In fact, we're working with your team on it. I was in Hopkinton last week. Lovely fall day, by the way. I don't know if you had the team order that up for me, but doing some hands-on work with PowerScale up there. And yeah, I mean, we all know the read performance is good. What surprised me was what we saw on the write performance, which is at times where QLC can be troubled because what. I don't want to get too far down in the weeds, but the QLC drives have an indirection unit. Right now it's 64K. That's how they want to be written to. They want it to be nice, sequential, friendly writes to the drive to maintain performance. And I guess in the software, somewhere along the way, you guys have figured that out to make sure that you're writing to these drives the way they want to be written to. And if you do that, if you can coalesce those writes before they go to the drive, then you're pretty much golden, right?
That's exactly what we do. And we are. So, I mean, I think we're not done squeezing right performance out of these things yet. So,
Wow.
our engineers
Okay.
are working on it right now, but we might be able to squeeze more. What's nice is we were able to squeeze more read performance. So, I think we announced it at Dell Tech World, so I'm not out of line saying it, but in our upcoming 1FS release, we'll actually give you 25 to 30% more streaming read performance with a software upgrade. So, we're not done squeezing more juice out of this orange.
So talk about then how your customers are using these drives. I mean, I'm sort of conflicted on this because I feel like when you go with a density message of, hey, customer, with TLC, we're capping out at 8 terabyte drives or maybe up to 15.36 in a few cases, but those are really quite costly when you start to get to the large capacity TLC drives. Be that as it may, we can now get maybe 4 to 8 times more capacity depending on what you're coming from in these systems. Do you worry that customers will buy fewer nodes because they don't need them for capacity?
I mean, I would be worried if they weren't doubling or tripling their footprints every year. The reality is
Okay.
that some of our customers who are consuming this class of node for performance and density, we'll go through some of the workloads in a moment, but the amount of data that they're gathering is it's nonstop. And what we're seeing is that, whenever you put out a more dense node, customers will gravitate towards it. So you put out a 15 terabyte drive, that's one thing. If you put out a 30, you guarantee that the 30 is going to outsell the 15.
Really? Wow. Is that specific to unstructured that you see that happening more? I mean, I guess because the media explosion, everything's just as you said, nonstop. So
At the end of the day, I talk to customers who tomorrow they might have to pick up a 6 petabyte additional data pool. And where am I going to put that in my data center? How am I going to catch all of that? And how am I going to do it in a cost-effective way with rack power sometimes being constrained and rack space constrained? It's a tough problem. So density rules. Now, don't get me wrong, performance is important too. And so we're continuously working on both. But we'll keep striving towards density.
So what do you have to do? I mean, obviously adopting the 30 terabyte drive helps on the density side. Do you, as you said, the data sets are expanding, but these guys are constrained in many times, rack space or power or cooling or whatever. Do you need to do more dense 2.5-inch drive chassis? Like what else can you do to continue to help on the density messaging?
I think we have to look at some, new design paradigms. Certainly, we're exploring a few. Without going too much into it, there's several new different drive form factors. But that said, I don't think that we're capped out on the maximum right now with 24 and 2U. So I think there's more that we can do to jam more drives in there. One thing that you have to think about as being a differentiator between us is we're not doing this like complete and shelf model. So with where you potentially don't have compute along with storage, you might get misinformation about how much real density you have. We scale compute and storage together, and if you need more performance for your data, you really need a performance dense set of data, then you might buy smaller drives. So you might use 4 terabyte or 8 terabyte drives when I really have to just do a ton of performance out of a small data set. But for customers who've got lots and lots of data, and that data is continuing to grow, and it's not all active at any given time. What percent of your data actually needs that performance at any given time? Is it 20%? Is it only 10%? I'm sure it's not 80%. Then you basically will tune the density to be as rich as possible when that percentage grows smaller, so you're maintaining the performance, but getting the cost efficiencies and the power efficiencies that density drives. And so that's really the question we're thinking is like, how much more density can we actually physically fit into a certain amount of space while preserving the performance or even getting incrementally better in terms of performance?
Yeah, you talked about form factors. Obviously, like E1L would be, a great one, or an E3 or some of these other ones where you can get the nice long NAND packs with plenty of cooling around them with the heat sinks. Has a lot of potential in terms of the capacity that you could jam in there for sure. That would be very few mainstream storage arrays have moved off of U.2. I don't, customers know it and like it. I mean, so we were talking about your adoption of QLC and it being very good, and I'd be curious kind of to dive into that more. But normally we hear a lot of FUD marketing around new technologies or new shapes or whatever because your competitors may not have that, so they go straight to endurance, whatever, and try to cloud the waters a little bit. But it sounds like your customers are still adopting regardless and really like what they're seeing from these high density QLC drives.
Yeah.
I'm just curious how much friction there's been in that sales process.
There's been a few calls I've been on with customers to walk them through why we're comfortable with the QLC drives. Largely after seeing the data, which is we just publish it to them as plain as can be. Those concerns largely fade away. In fact, I haven't seen a situation yet where they haven't just been, okay, well, that looks good. That said, in terms of, how we're going to pack more in, there's all kinds of different ideas right now. So I know there's a few that we're pursuing. It's a little bit too early for me to call it yet, but understand that, I fully appreciate the benefits of getting as much density and compute together at the same time as possible.
So when you guys made the announcement back in May at Dell Tech World, you announced the support for the 15.36 and the 30.72 QLC drives. which
Yeah.
was pretty neat, but also a little bit surprising because historically, Dell has been very much in the storage world about multi-source everything. But when it gets to QLC, that level of competition isn't there. I mean, Solidigm has the drives I just mentioned. They're the only ones really at scale with those drives, so it was pretty obvious, what you guys, who you were working with there. But that's a fundamental shift, at least from what I'm aware of in your world. Does that matter? Does the multi-source issue, like, how do you address that, or do you care anymore?
Well, you always want to be multi-sourced, right? As much as you can, as much as makes sense.
Mm-hmm.
And so we encourage all the drive vendors to look at 30 terabyte QLC as being a good opportunity. I mean, that said, the opportunity is just too rich to go after, to pass up for lack of another vendor there. So, we have a good relationship with Solidigm, and they came through. They really did. So, what can I say other than just, it's solid. Um,
Right.
so look, the moment that something else comes out, we'll take a look at it too. But right now, that's what we have, and our customers are demanding that, and that's what we're giving them.
Well, sure. So I guess if your customers are saying we want greater density, and you're looking around saying, "Is there a good solution for this?" Yes, there is. Then go for it, right?
That's right.
Yeah, that's pretty neat. Again, I mean, from the performance profile standpoint, when we started going through the data with your team and doing some of that work, I fully expected. I'm still surprised. We haven't published it yet. We'll get there very soon. But the performance on the right side, I know we already talked about it, but I'm still stuck on it because that was the one thing that I'm like, well, how's Dell going to go to market with this? Talking to customers about understanding how much write impact you have and blocks, because that's going to be really confusing and a little bit sloppy of a sales motion to say, it only works on real large block. But I guess again, kudos. There's not much else to say, but you guys have done a good job to figure that out.
In some ways, Brian, I would almost say it's just luck. Like the way that OneFS writes data to these drives happens to work really well, right? We do coalesce writes. We do a lot of write preprocessing. The data comes in and it's handled in a way that makes it possible for us to actually go and ensure that we don't cause damage going in, and we can ingest at a very high speed and make sure that we distribute that load across all the nodes in our clusters. So the advantage of that is that, well, it turns out that we're pretty easy on the drives underneath, pretty gentle on them. It's not like one data is coming in and it's hitting a very small set of drives. It's actually going across every node in a cluster up to a reasonably good sized cluster, and every drive inside. So we're pretty well distributed, and that means that every drive is just seeing a fraction of that I/O, and that takes a lot of the pressure off those drives.
Do the large capacities cause any new challenges? I'm just sort of thinking through what happens in OneFS if the node that was 60, 80 terabytes before is now almost 3/4 of a petabyte. Does that just massive data cause any new table indexing? I don't know. Any other challenges for you that you had to work around?
Not yet. We calculated a number called mean time to data loss, which is a calculation of, given the size of the node, the number of drives inside of it, and what would happen if we had multiple failures at the same time, the probability of failure occurring with the drive or the chassis itself. How long would it take before enough failures occur that you actually experience data loss? And we try to keep that number in the thousands of years mark.
Yes.
In 1,000 clusters, 5,000 clusters every year, you might actually have that happen. But very few of our customers have 5,000 clusters. So generally speaking, we're fairly okay. Now, of course, we that's the lower limit. So we always try to go beyond that. If we ever ran into a case where the size started to impact that, we would probably start to ratchet up our protection levels. And so you'd start to trade a little bit of efficiency. And this is what everyone who kind of uses this technique of erasure coding across drives to get endurance will do, is they'll start to trade off efficiency to get more durability out of the system. And so we have that lever at our disposal. Fortunately, we didn't have to use it this go round.
Oh, that's interesting. So you would overprogram your resiliency if you felt like you had to deal with a less reliable part, whatever the part is.
Correct.
Huh.
Yeah.
Well, so that's good. That's you get all the benefits now, and you haven't had to work real hard to get there outside of your traditional qual process, and the fulfillment and support arm to supply these things out to the field to deal with potential replacements or whatever.
I would say the most important thing is that we did the calculations, that we did all of the qual, the testing to make sure that this was a high quality product that met those endurance levels that I described earlier, so that our customers who are running, I'd call them mission critical applications. They're not Oracle databases, but they certainly are business critical for those customers. Mm-hmm. In some cases, if it's life sciences or healthcare, then it's very mission critical, and can feel comfortable with the data. So I agree. Like it was a fairly engineering light lift, but we had to make sure that we ran it through the paces.
So for those customers that are worried about that still remain worried about their write impact on the drive in terms of endurance, we talked about the drives have telemetry. Your system has telemetry. If they're in a current PowerScale system, is that something that you can? I don't even know how that looks in OneFS. Is that something that they can see, or something that you can tell them? Hey, customer, I know you're worried about your writes, but you're at 0.2.5 drive writes per day, which is well below the spec. And can you see that in your systems and share that with the customers to help them feel more comfortable?
Both. You can report on it through command line interface or APIs, and you can see it in alerts. If we were to run into a situation where a drive was experiencing errors, we would know about it. You would as well.
Right. But you could also tell them, like, hey, looking at your current workloads, you're well within the window for what we can handle with this particular drive spec.
Yeah, there's ways of reporting on that. That's right.
Okay. So the other big, yeah.
It's like it's belt and suspenders, right? So the belt is like, we did the testing. We feel good about it. The suspenders is that there's enough alerting and reporting capabilities in the product that if you were to get near the rails, we would know, and you would know. Or if you're getting to the rails.
So your next challenge then will be to push these guys to crank out a 64 terabyte part, so you can continue to pitch your density story in PowerScale with new, bigger drives, huh?
Oh, well, that'll be the next challenge for sure. We'll see whether we have to make any adjustments to accommodate those. But I would imagine that we're all looking for that. I think that drive vendors as well as storage vendors appreciate the value of density, and so I would imagine all of us have got that goal in mind.
Yes, I suppose so. So you talked about security. That was the other thing that you guys were excited about from a OneFS perspective back at DTW. Everyone's worried about cyber resiliency and attacks and everything else, and file data, unstructured data, is kind of one of the more dangerous spots, I would think, with so many points of exposure, all the file data that could be corrupted or attacked at any time. How much responsibility falls on the array for that versus storage or versus backup software or other protection applications? How do you view that?
That's a great question. So I happen to own cyber protection products on both of those portfolios. And so it goes back to belt and suspenders. I kind of feel that it's a nuanced discussion, but it's an important one. If you're backing up data, you have a responsibility to make sure that backup is secure, because that's your last line of defense for your business. Hopefully you're backing up data that requires backup, because backup infrastructure is not free. And so if somebody attacks a backup and that backup is destroyed, you've just lost your very reason for having backup to begin with. Which means if somebody were to accidentally delete something or something bad happened, you have no way to recover. So let's just put that on the table, that your last line of defense is your backup. And if you're backing up data, you have to find ways to make sure that that data is impregnable, that you've got the right checks and balances in place to make sure that any latent threats have been discovered and that you have a fast way to remediate against them. If something's been corrupted in some way, shape, or form, and you find out about it, that you have locked down your system and you can go back to a last known good copy and figure out where that was. That said, when you talk about unstructured data and file data, oftentimes it will reach a scale where backup products simply don't usually extend into. So if I'm looking at a customer who's got, let's use this 30 terabyte all flash unit, and they went and built a 30 petabyte cluster out of it, the likelihood is that they're not backing that up using traditional backup infrastructure. And so
it's just too big, right? Too cumbersome?
So quite possibly they're just replicating snapshots and locking down snapshots at the secondary location. Great. Now, if an attacker gets access to the primary and starts to encrypt data, that'll get replicated to the secondary. And so
yeah, it just passes through, and now you're in trouble on both accounts again, right?
Exactly. So just like I put a lock on my front door, if an intruder gets through the lock, I have to have a secondary security system. And so I have cameras around my home. And
I thought you were going to say a shotgun, but okay, camera's fine.
yeah, well, a little more innocuous, but
fine. In the Midwest, we do things a little differently out here.
I'll make sure not to break into your home.
Thank you.
The point being is that what we do on the primary side is it'll expand to include scanning, but right now it's heavily focused on the actual user behavior. Because if in the case of primary, there's a lot of data to go analyze and figure out if something bad happened over the last course of time. So instead, I'm looking for what's happening right now. Are people accessing data they're not supposed to? Are they behaving in ways that they're not supposed to? And I want to be able to lock that user out of the system, revoke their privileges. I still want an air gap solution so that I actually have a completely remote version of the data that cannot be accessed by intruders who are vectoring in from the primary. So that basically behind the vault type of a solution that opens the gate periodically and says, hey, is everything okay? Send me what you got, right? And then locks up. So an intruder can't get in, but it keeps multiple point in time copies that are immutable. So we have that type of a solution as well. If your system is small enough that you could back it up, you have the option to do both. You could use the backup with a cyber protection to make sure your backups are not, because typically a backup system is not just for one NAS. It might be for multiple NASs. It might be for a NAS and a couple of databases and a few VMs that are running over in a pocket somewhere else. You still want to lock it down unless you've dedicated that backup system to that NAS. And then on the NAS, you probably want to lock it down as well, because detecting right away that someone's breached your environment or somebody's behaving in a way that's apparent is important, because otherwise it'll just get propagated to the backup. You'll still have to restore, but you're just going to propagate the problem. So the sooner you shut it down, the better. And so there's both of those solutions in place, but it's really kind of a user has to decide, if I'm backing up, I have an obligation to maintain the integrity of my backups. If I'm running primary, there's oftentimes cases where I just simply cannot back it up. Therefore, I will want another way to secure it. What I like about what we've done in PowerScale is that if I look across the solutions in NAS, some of our competitors, nobody has a nice vaulted solution the way that we've built it with a full air gap. It's an inside the vault solution. An attacker cannot vector in. It's a different set of administrators potentially, and it periodically checks so that the gate is not constantly open to figure out what to do next. And that really sets us apart.
Well, talk about that a little bit more from a process standpoint, because you're talking about storage admin stuff. You're also talking about IT sec stuff at the same time. Who's, in the orgs you work with, who's really taking ownership over data security for what you do, for unstructured? And how much of that is a security issue? How much of it's a storage issue? How are orgs adjusting to deal with these risks more or less in real time, as you describe it, rather than retroactively, let's go to the backups to find how far back we've got to go to get one that's not infected or whatever, where this thing wasn't lying dormant. But in the real-time model, how are you seeing that work with your customers?
So, obviously, a lot of this is being driven by the CISO. That's their charter, that's what they're looking at, and then they're driving it top down. That said, it doesn't take long to look around on the news and see how often these breaches are occurring. If I'm an infrastructure owner, I'm going to be paranoid about my data. And it depends on the organization, but a lot of these, we were talking about these high performance drives, a lot of them go into regulated industries who have penalties that they have to basically cough up or have to deal with the repercussions of their data being offline. And so it's kind of coming from both sides. I would say that in the space of backup, the folks who are focused on backup and have that as a job title or as a responsibility tend to be more attuned to it in terms of the urgency around implementing these solutions. But I will say that at the same time, in the file space, I think we have over 1,000 deployments of the ransomware defender products. So it's not like it's not there. It's pretty well understood. Will we do more? I think that'll increasingly become something that is just going to be check the box, has to be part of the order, coming from our customers, not just us. But I do think the backup administrators are ahead. I do think that the conversation starts with the CISO, and you meet in between.
So I'm thinking through from a portfolio perspective, and I know the rest of these things aren't under your umbrella exactly, but can Dell take what you've learned here on PowerScale and, for lack of a better word, port those types of security solutions to Scale and Max and Flex and all the other stuff that you offer? Is that part of, we haven't ever talked about this before. I'm just wondering how much of that universalizing some of these chunks of functionality can happen and then spread across the portfolio.
So good, interesting. You asked me that question. PowerMax recently implemented some metrics that can indicate whether or not they believe that something bad is happening in your environment as well. That gets sent up to a security index that's reported on in Cloud IQ. And so all of the products will start to report on some of these metrics within Cloud IQ to show at a base level, is there a score that you can look at that tells you, hey, I think there's something going on, or it looks pretty clean? That's at least kind of your first line of defense, not your last line of defense. Obviously, you may want to get more sophisticated than that, and that's where some of these additional product offerings come in. And we do take a good, better, best approach, right? So all of our products have immutability to some way, shape, or form. So you can always turn on immutability and with retention lock and prevent someone from being able to delete something, and look at some reporting metrics to figure out whether or not something is going on. The next level is the user behavior and actual content analytics, and being able to create a vault is another step. So, and it's almost like the other order. It's actually immutability is kind of how do you protect your data? Then there's isolation, which is how do you put it in a location where an attacker can't easily vector in? And there's intelligence, which is how do you look at either attacker behavior or scan the data itself to look for something that I can notice that to the ordinary eye might not actually look like an attack, because some of these attacks are getting so sophisticated. They might flip only a few bits. That's enough to really mess up your data and extract a ransom, but it wasn't enough to really trigger anyone that something really bad happened. So it might stay dormant in your environment for months before you actually detect it, unless you had some AI ML that was learning from other people who got attacked and go, oh, wait a minute, whenever I see a pattern that looks like this, that's an attack. And so we're building all of those capabilities into all of our products, and each one of them will essentially feed into different levels of scoring, whether it's just a security metric that's reported on in Cloud IQ, or a more sophisticated product offer, or maybe the best product offer, which includes an air-gapped vault.
That's interesting. Yeah, I mean, we know that the backups are now the primary target for ne'er-do-wells that are looking to cause problems. And as you said, the data suggests pretty heavily that they will sit as quietly as possible for some period of time, because then you end up backing up, and now you could have months or day. I mean, who knows how long that piece of nefarious code or whatever is there, just kind of waiting to be activated. But I do like the notion of taking everything you've learned and not just leaving that in one customer's library, but let's say, let's be collaborative here and take these signatures and these behaviors and figure out a likelihood that this has shown up in your environment, and if so, here's what we need to go do to remediate it before it's a serious problem. I mean, that's got to be a big part of the future for getting out ahead, or as ahead as you can be on these attacks, I would think.
That's right. I mean, it's really become like an antivirus type world out there. We have to get smart about how malware is making. This is a form of malware, right? Making its way into your system. So try to do that as much as possible.
You made a comment before I want to revisit for a second about the unstructured data at scale being really cumbersome to back up. And it's not something that I've thought a lot about. Is there a common wall that customers hit? Where is it 10 petabytes, 20? Is there some number where they're like, okay, once we get this far, it's too hard or too expensive or too slow or whatever?
I mean, I don't want to throw numbers out there and get people, wrapped around them, but
Okay.
there is probably a scale where you're either saying, okay, you know what, I'm not going to back up everything. I'm going to be more selective about which data sets within my environment I back up.
Okay.
What I'll tell you is that, it's not uncommon for us to see 10 to 20 petabyte plus environments, even 200 petabyte environments, not completely uncommon. And so at that scale, the backup infrastructure to support it would be enormous. And so, for a number of different reasons, including the change rates would be just off the charts. Mm-hmm. So, there's probably in that petabytes, multi-petabytes range where customers flip over to either doing selective backup of just a portion of their environment or just using replication and snapshotting as a way to protect their data.
Does this then, I mean, we started out talking about Apex and Alpine. This has got to have, Alpine specifically has got to have your customers pretty excited, because now if I can ad hoc spin up a couple petabytes in a cloud of OneFS and use that as my replication target, rather than whatever they do now, copying the infrastructure or taking old nodes and making those replication targets, or doing it on disk because it's more cost effective or whatever. Like, there's a lot of other expensive and or suboptimal ways to do this, but Alpine seems potentially like a really great fit for these guys that are too big, or for anyone that wants to replicate this stuff off and still have the accessibility to it, or fail to it if they have to.
Oh yeah, I mean, all kinds of interesting topologies pop up for just a one-time burst to cloud, because I need to go stand up a pretty large cluster. I've got the data, but I don't want to go buy 10,000 compute nodes for a day. So I'd rather just rent them from the cloud, to what you said, like, let's do periodic updates, and maybe we'll spin down the data during times when it's quiet and spin it back up and catch up to where it was before, to find out ways to kind of keep, cost in line. There are strategies we're looking at in the Alpine space around tiering your data off the cluster completely and just sending it down to really low cost object storage. It's the ultra cold archive.
Right.
And so all of these things come into play. And then there's just a pure agility play. Like, I happen to be in a fortunate spot in that Dell is a pretty large vendor of both software but hardware as well. And as a large vendor of hardware, we enjoy really good relationships with our suppliers, which you talked about earlier. And so typically I can supply my customers with gear when they need it. But some customers, or some of our competitors, may not have that luxury. And so if you've got an environment where you've got rapid change and it's unpredictable, And so I'm looking at something that might grow by 2 petabytes tomorrow and 7 petabytes the day after, and who knows what the day after that. One of the advantages that cloud gives them is that almost instantaneously accessible supply chain.
Yeah.
I don't have to worry about, oh, it's going to half a year to go get my gear. Okay, well, let me just hang out and wait. I don't have that luxury. If a customer doesn't have that luxury, that agility is pretty critical.
Well, sure. It lets you spin up almost instantly, right? As fast as you can swipe your credit card and be on your way, huh?
Correct.
Yeah, I mean, this is a good conversation. We've covered a bunch of stuff I didn't expect to, so I appreciate that. It's always fun to go in and learn more about what's going on. It was great to be back in the lab in Hopkinton again. It's been a little while since we've done that, and seeing some of this technology come to fruition, the hardware bits. I mean, I know you guys are really into the service and cloudification of everything, but I like to see and touch stuff still. So it's good to be hands-on with these things, and it's real. I mean, I don't know exactly how long you've been shipping QLC, but I saw it in a number of the nodes on site as we were messing around there, and yeah, it's pretty neat to see.
Yeah, I mean, look, hardware's not going away, right? I mean, in fact, if anything, for these really large environments where something like 30 terabyte makes sense, we see that the cost of running in cloud, unless you really need that agility, it's not cheap. And so our customers are going away from the mentality of cloud first to like cloud when it's right,
Right.
So they have to do that little back of the envelope calculation to say, hey, wait a minute, is this a good environment for cloud, or is this one I might keep on-prem? And at very large capacities, and again, I mentioned 200 petabyte, that actually it's a thing. That calculus works in favor of, wow, that's a big chunk of change I saved by staying on-prem. And so I don't think that it's going to dry up in terms of the demands around density that we talked about earlier, and performance and large cluster sizes. Like all that stuff is all going to be there for the foreseeable future.
Well, we one of our most popular social media videos of the last couple of weeks was the Buffalo Bills coach. I think it was the offensive coordinator that was freaking out, smashing everything in his coaching booth after they couldn't get the snap off, and we clipped that, and the tagline was something like, "Your CFO after they get their first cloud bill," which is kind of what you're talking about, right? Is that it's maybe that was a dramatization via meme, but it can be hard sometimes to really estimate and get a full handle on what that is. And again, what you're talking about at scale with unstructured can be insanely expensive if that's not value optimized for your workloads and what you're trying to do as an organization.
Absolutely. Yep. I mean, it's the difference between rent versus own, right? I mean, when you're going to go on vacation, you don't just buy a home in the place you're going to unless you can absolutely afford that. And congratulations to you if you can. But it's a temporary thing that you need, then you go rent it. Or if it's something that you need sporadically, that might make sense too. But to Airbnb every day doesn't seem like a good way to manage your capital.
No, especially since they outlawed the parties. I'm not an Airbnb guy anymore, so ruined my whole vibe. Got to cut back on that. Well, this is great. We've got a report coming out in a couple weeks that's going to dive way into all of this stuff and cover it. And normally I would have you on after we publish the report, but so it worked out to get you on before. So this will be a great teaser for anyone that wants to learn more about what's going on with PowerScale, what you guys are doing with QLC, some of the performance data you talked about. We'll have some numbers to look at too, and I think it's great from a storage, just selfishly as a storage guy, to see a vendor out there pushing the limits of what can be done and addressing customer needs with great products and being unafraid to go do that. And so I give you guys a lot of credit for that.
Well, thank you. Appreciate it.
Thanks for joining us today, David. Appreciate it.
No problem. Anytime.